All right. So again, happy Wednesday, happy hump day, middle of the week. So yesterday at the end of the period, we started to talk about trigonometry. No, I haven't. Some of you are asking, I haven't graded some late work. Yeah, a lot of people are turning in late work, and I will get to it. I will definitely get to it before I have to turn in grades on Thursday. Yeah, I will not leave it. That wouldn't be nice to leave it after I turn in my progress report. Even though it's only a progress report, I still want to grade the late work before I turn it in. So yes, I will get that. No, don't be sorry. You need to be concerned about your grade, and I like that. And you need to question your teachers about your grades. If you turn something in and it's not graded, yeah, it's okay to send a question and say, hey, can you grade that before you turn in grades, please? So that's fine. So we started talking about trig, and we got some definitions of trig. We got the official definition, and then we got just basically the casual definition of trig. But it basically has to do with triangles, right? And the first introduction to trig is looking at right triangles, because those are the nicest, the ratios that we're going to use to start off talking about trig. And we'll talk about those ratios in a minute. But first, I want to discuss and do a little warm-up of the basic thing you learned about right triangles, and that's the Pythagorean Theorem, right? Pythagorean Theorem. And if you forgot what the Pythagorean Theorem, right? Some of you know it as a squared plus b squared equals c squared. I think that's not the best way to learn it, but if that's the way that's the way you remember it and it helps you, that's fine. I would prefer you to say leg squared plus leg squared equals hypotenuse squared. Okay. That way, A, B, and C are just arbitrary letters. That way okay, the two legs have to be squared and added together and get the hypotenuse. Because some people were sending me answers to this warm-up, and they were wrong because they used these two as A and B, or leg and leg. And so the first thing you always have to do, even if you don't draw it, the first thing you always have to do when you see a right triangle is you need to identify what the legs are and what the hypotenuse is. You should always, even if you just eyeball it with your brain and just say, okay, those are the legs, that's hypotenuse, that's fine. I like to color code mine so I know this is a leg. How do you know those are the legs? Because those are the two sides that make the right angle, right? The two sides that make the right angle are your legs. And this long side that's across from the right angle, that's your hypotenuse. Okay, so the first thing you should do is identify what the legs are and what the hypotenuse is. Once you know that, then you know, okay, leg squared plus leg squared equals hypotenuse squared. And it's going to help us when we do our trig ratios too. So leg squared, so let's get one leg. One leg is 15, the other leg is x. So 15 squared plus x squared equals hypotenuse squared. The hypotenuse is 25. So that's 25 squared. So hopefully you guys set it up correctly. If you didn't, some of you had the 25 here and the x here, and that's what messed you up, right? Leg squared plus leg squared equals hypotenuse squared. These are the two legs. All right, and then from there, you just solve. 15 squared is, good job, 225 plus x squared equals 25 squared is, what's 25 squared? Anyone? $625, very good. And so if I want to get the x by itself, I'll just subtract 225 from both sides. And we get x squared equals 625 minus 225 is 400. And then again, how do I get rid of a squared? What's the opposite of squaring a number? Good job, square rooting a number. So I just square root both sides, cancel, cancel. So x equals the square root of 400, which is what?
21.
No, it's not 21. It's 20. Very good. It's 20. So this side is 20. So if you know two sides of a right triangle, use the Pythagorean theorem to find the third side. You're going to need to do this sometimes when we're doing some trigonometry. I'm a little sad that we're not all in school normally, because then this week we would all be going outside and finding the heights of different things on campus. But luckily, some of you that are going to retake this class next year, maybe we can do it next year. Just kidding. All right. Any questions about Pythagorean theorem? No, you're good? Okay. I'll leave this up for 10 more seconds. And then we need to go to our trig notes. Five, 4, 3, 2, 1. Okay, so in Schoology are your notes. Just go to Schoology and someone in the chat said, no need to expose us, Mr. Damn. Sorry. I will see maybe a couple of you next year in this class again. No. Everyone in this class is going to pass. Somebody asked me to go back up. Okay. Everyone in this class is going to pass, right? Everyone's going to do their work, get this class over with, not have to take it in summer school. All right, I'll leave it up for 10 more seconds. I am recording this, so this will be in the video. I'll put it up right after school. Yeah, I can't put it up after class because I have last period. All right. 5, 4, 3, 2, 1. All right. So yesterday we started talking about trigonometry, and then we said, what is trigonometry? And someone in the chat said, it's the branch of mathematics that studies relationships between side lengths and angles of triangles. And that just came off right off the top of their head. I was really impressed with them. Right? They didn't look it up or anything. That's just that they knew that, and I was very happy with them. And that's a great definition. That's an official sounding, right? All those old mathematicians that meet every year to determine different things in math, they would love that. If you want to be a little more casual, you can just say trigonometry is the study of triangle measurements. That's it. Okay. And the way we start with trigonometry is we look at right triangles. And the reason we look at right triangles is because we want to make these ratios, right? So these ratios we're making are in. Okay, that's fine. Hold on. Give me 1 second, people. Okay, so these three ratios. So here's a right triangle, okay? Here's a right triangle. And again, you should always identify the legs. So these are the two sides that make our right angle. So these are the legs. And this long side, the longest side of a right triangle, is the hypotenuse. So always understand which, because it may be in different configurations, right? But always know where your legs are and what your hypotenuse is. And so what these are is so mathematicians a long time ago, probably the Greeks, but it's probably other societies around the world too. They're like, what if we made some ratios? And again, don't be alarmed with the word ratio. I don't know why so many students see the word ratio and they freak out. Even my decathletes, the decathlon team, when we were doing the math stuff, when we were talking about ratios, they're like, oh, those are hard. Those are difficult. I'm like, wait. What do you mean they're hard? They're difficult? Like, yeah, ratios are so difficult and stuff. I'm like, wait, all the ratio is comparing two things. That's it. And the most common way we write a ratio is a fraction. That's it. They're like, really? That's all a ratio is? I'm like, yeah. We use ratios to figure stuff out, like scale factor and similar triangles. And you know how if you ever had a model car, right, or a model anything, right, and it tells you what the scale is, like 1:5. Usually in those contexts, they give it to you with a colon, but you can write as a fraction 1/5. And that just means the model is 1/5 the size of the car. Or if you look at the ratio the other way, the car is 5 times bigger than the model. That's all it is. So that's all we're doing here. So when I say these words over here, and you'll look at see sine is one ratio, cosine is another ratio, and tangent is another ratio. All we're doing is making a ratio of sides. That's it. So when I say sine, we're going to find the sine of an angle because we're going to either be standing right here when we find sine, cosine, or tangent, or we're going to be standing right here. Okay, we're going to be from the perspective of one of those angles. And that's it. If you know which angle you're standing at, then finding sine, cosine, and tangent is easy. You just make a fraction. How do you do it? Well, let's look at sine. Sine is the ratio of the leg opposite the angle to the hypotenuse. So basically sine is just a ratio that says opposite leg over hypotenuse. Okay. So, and it depends on the angle. It depends on what angle you're doing. So like you'll see something like this. You won't just see sine. You'll see like sine of A, right? That means the sine of A. That means I'm standing right here. That's the angle. And so the opposite leg is over here and the hypotenuse is over here. So that would be my sine. This over this. And of course, there'll be numbers here. You need to know these numbers. Okay, that's it. Sine is the opposite leg over the hypotenuse. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So cosine's ratio is just adjacent leg. What does adjacent mean, mister? What is adjacent? Adjacent just means next to. Okay, adjacent means next to. Opposite means on the other side, right? And so cosine is just the adjacent leg, whatever length that is, over the hypotenuse. And then tangent is our third, and that is just the ratio of the leg opposite to the angle to the leg adjacent to the angle. So tangent, we use a lot of tangent in real life. So tangent is just opposite leg over adjacent leg. So we don't even look at the hypotenuse at all. So when we don't know the hypotenuse, we use tangent. So if we're trying to do any problems, and we don't know the length of the hypotenuse and there's no way to find it because, maybe it's somewhere in real life, we can't find that, we can just use tangent and use opposite and adjacent leg and don't even worry about the hypotenuse. Yes, if you know the opposite and adjacent leg, you can use the Pythagorean Theorem to find the hypotenuse. Yes, that is true. Someone said that in the chat. Good job. But sometimes it's just easier when we're doing stuff to use tangent. But we use all three. Okay? So do you have to memorize this? I don't think you have to memorize this. I don't believe in memorizing most stuff because you can look things up. But I do think you should have this in your notes. I do think you should highlight this and put stars around it or something, put arrows. I don't know, whatever you want to do. This is the beginning of our notes. This is the thing you should know. When I'm finding the sine of an angle, I'm finding the ratio, a fraction, of the opposite leg to that angle and then the hypotenuse. When I'm finding cosine of an angle, I'm finding the length of the adjacent leg over the hypotenuse. And when I'm finding the tangent of an angle, I'm just finding the ratio of the opposite leg over the adjacent leg. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. So this is what you need to know. So I'll leave this up here for a second for you to copy. And then we'll continue. Because the whole point of this is we're going to use these ratios to figure things out in triangles, to figure out side lengths. And then tomorrow we'll figure out angle measures. Okay, so this is the last lesson you're going to have before we start testing on Tuesday next week. Okay, sine, opposite hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Now I'm going to show you a made-up word that can help you if you do want to memorize these, if you do want to have these in your brain when you're doing problems. And I'll show you that in a second. But some people say they need to copy this down. Again, this will be in the video. You can go back to the video and pause it and write this down later if you don't get everything. Because I'm not trying to rush, but I do want to go over these problems before we run out of time. Because we have today, tomorrow, Friday, and Monday to go over this and make sure we understand it, and go over problems and examples and ask questions before we start. Because you will see this on the SBA, on the SBAC, however you want to say it, starting Tuesday. All right, 5, 4, 3, 2, 1. All right, so you want a shortcut to think about this? Here's a fake word that a lot of trig students learn every year. It's a fake word. It's not real. But here we go. So, ka, toa. And so, let me go back here. You see how that's sine? The shortcut for sine, you'll just see S-I-N. Okay, that means sine. The shortcut for cosine, you'll see C-O-S. And the shortcut for tangent, you'll see T-A-N. And those are all in your calculator. Okay? All the sine, cosine, and tangents for all right triangles have been figured out. My teachers used to tell me, back in my day, we had to look these up on tables. But calculators were invented, so we use calculators to figure it out. So that's why we can, if we know the angle, we can use our calculator to figure out some sides. So sine is S-I-N, cosine is C-O-S, tangent is T-A-N. You've seen those on your calculator. So SOHCAHTOA is a fake word, meaning S-O-H, means sine is opposite over hypotenuse. Ka, the ka part of this word, is cosine equals adjacent over hypotenuse. And then the toa, T-O-A, part of the word, is tangent equals opposite over adjacent. So SOHCAHTOA is a way to remember. Like if you're thinking, wait, what was sine? Wait, what was cosine? Wait, what tangent was? You can just think, SOHCAHTOA, S-O-H, opposite over hypotenuse. C-A-H, adjacent over hypotenuse. T-O-A, tangent is opposite over adjacent. This is a fake word for you to remember the 3 trig ratios. Okay, so now let's actually do it. I'm going to give you triangles, and we're going to write the sine, cosine, and tangent of one of the acute angles. Then we're going to write the sine, cosine, and tangent of the other acute angle. Now, you're not going to find the sine, cosine, and tangent visually of 90 degrees. It's always going to be sine, cosine, and tangent of this acute angle or this acute angle. Okay, not this angle. We're not going to find the sine, cosine, and tangent of the right angle. Okay, we can do that with the unit circle later, but for right now, just visually using a right triangle, we're going to find sine, cosine, and tangent of this or this angle, those two acute angles. Okay? So let me show you what I mean. So let's look at example number 1. Okay? Example 1. So if I look here, that side and that side are my legs. And this side is my hypotenuse. Right? And so I'm going to focus in on angle A. So my focus, always know what your angle is. So my focus is angle A. So I'm going to find the 3 trig ratios of angle A. So that's what this is. Sine A, cosine A, tangent A. Okay? So if we're at angle A, what's the sine of angle A? So that means if I'm here at A, sine is what? Sine is, let's go back. Sine is opposite over hypotenuse. So if I'm here at angle A, what's the opposite leg? What's the length of the opposite leg? Anybody? Anybody see it? What's the length of the opposite leg to that angle? Because when I say opposite, I'm meaning opposite from that angle, because that's the angle we're focused on, 5. So that means 5 goes up here. And then what's the hypotenuse? 13. That's it. 5 over 13. You're done. Sine of A equals 5 over 13. It's that easy, mister. Yes, it is. It's that easy. It's just a fraction. Right? So we're learning right now to set up the equations, because we're going to use these equations to find the pieces that are missing. But we have to know how to set up these equations. Okay, what's the cosine of A? Well, cosine is, let's go back. Cosine is ca A over H, adjacent over hypotenuse. So if I go back over here, the cosine of A, so if I'm at A, what's the leg that's adjacent to A? What leg is adjacent to A? 12, right? Now don't say 13. Mister, this is adjacent to A too. Yes, but that's not a leg. That's the hypotenuse. So yes, it's 12. And what's the hypotenuse? 13. So my cosine of A is 12 over 13. That's it, mister? I thought this was complicated. You thought wrong. It's not complicated. And so again, now we're still at A, right? We want to find the tangent of A. So again, tangent is, let's go over here. Tangent is TOA. O over A. Opposite over adjacent. So let's go back. So if we're at A, what's the opposite side? 5. What's the adjacent side? 12. So this is 5 over 12. That's it. Okay, so I'll give you a minute to copy that. Any questions? Any questions on what sine, cosine, and tangent of an angle are? Someone says, Mister, what about C? We're going to do that in a second. I'm going to color that one a different color, and we're going to do C. Right, C is that one. How do you know which number to put on top? Right here. For sine, you put the opposite side on top and then the hypotenuse on the bottom. For cosine, you put the adjacent side on top and the hypotenuse on the bottom. And tangent is opposite on the top, adjacent on the bottom, right? That's what this whole top part was, explaining all that. So make sure you get this copied. Yeah, because that's the only thing. Like, yeah, Mister, which one goes on top? Which one goes on the bottom? It's all about this chart right here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and so those of you are asking, okay, what about C, Mister? What if I want to find all of that stuff, but for C? Okay, so the sine of C, cosine of C, tangent of C. Okay, so now we're here at C, and I want to find the sine. So how do I do that? Well, what's the sine of C? So if I'm at C, the sine is, if we look up here, the sine is opposite over hypotenuse, right? Opposite over hypotenuse. So the opposite side over the hypotenuse. So the opposite side is 12. The hypotenuse is 13. So this is 12 over 13. What about the cosine of C? Cosine of C is, while I'm here at C, cosine is adjacent over hypotenuse, adjacent over hypotenuse. So the adjacent side to C, the adjacent side is 5. The adjacent leg is 5. And the hypotenuse is 13. So that would be 5 over 13. And then the tangent of C, tangent is opposite over adjacent. Opposite over adjacent. And so if I'm at C, the opposite is 12. The adjacent is 5. So it's 12 over 5. So that's how you find the sine, cosine, and tangent. Okay, we're going to start using this to find out angle measures and side lengths. But I want you to understand what these ratios are and how to get them. Okay, so I'll give you a minute to copy these down. Ask me any questions you have. And then you're going to try it. And then you're going to ask me questions if you're still confused. Because once you know how to do this, once you know how to set up what sine, cosine, and tangent are, then we can start solving for stuff. But I want to make sure you know how to set these up first. Because if you don't know how I got these numbers, then you really can't continue. We really can't get to the parts where you actually solve and figure things out. Right? And what's the key? The key is here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. They're just fractions. They're just ratios. All right, I'd like you to try this. I'd like you to try number 2. I'd like you to try number 2. Right, I love this. Right away, someone in the chat said, "Mister, I don't see the hypotenuse. There's no value here, is there? There's no number here. So how are you going to, you need a number here in order for us to get a fraction. We need numbers, right? Is there any way you can figure out what this length is? If this is 9 and this is 12, can you figure out what that? And if you can't think of how, think of the warm-up. Right? Think of the warm-up. What do we do in the warm-up? So once you figure out this side, then you can fill these out. And I'll color this for you. Yeah, someone said, "Can you color it for us, mister?" Sure. These are my legs. This is my hypotenuse. Okay, W, right? W are for these ones. So you'll be at that angle when you find the sine, cosine, and tangent of W. And X, we'll color orange, and that'll be sine of X, cosine of X, tangent of X. Yeah, some of you tell me the colors help you. That's fine. Look, anything that helps you, use it. Right? If you like color, then use color. Yes, someone said, "Mister, do we use the Pythagorean theorem to find that side right there?" And the answer is yes, I would. So that's 9 squared plus 12 squared equals, this is hypotenuse, right? Equals hypotenuse squared. So I would solve that to figure out what this value is. Good job. Good job, chat. You're active in the chat. I like it. Someone in the chat said, "Hey, mister, can we use the Pythagorean theorem to find the pink side, the hypotenuse?" And the answer is yes. If you know 2 sides of a right triangle, use the Pythagorean theorem to find the third side, just like we did in the warm-up. So I'll give you a couple more minutes to figure out what H is, and then to fill in sine, cosine, and tangent of W, and sine, cosine, and tangent of X. Give you a couple more minutes. So yes, some people in the chat told me h is 15. They did the Pythagorean theorem. Someone just said, how do you know h is 15? They solved this equation. They solved the Pythagorean theorem to find h. H is 15. Now that you know h is 15, fill in sine, cosine, and tangent of w, sine, cosine, and tangent of x. So I want to do that quickly before we leave because we do have a couple of minutes. So really quick, let's start with the greens. So sine of w, so that means if I'm here at w, sine means opposite leg, which is 12, over hypotenuse, which is 15. So that's 12 over 15, which I can simplify. Remember, always simplify your fractions. If I simplify by 3, I get 4/5. Okay. Cosine of w. Cosine of w is, if I'm at w, right, we're doing w right now, the cosine of w. So adjacent side is 9, hypotenuse is 15, so it's 9 over 15. But again, I can simplify that, so I get 3/5. And then the tangent of w, if I'm at w, the tangent is opposite leg over adjacent leg. So it's 12 opposite over 9 adjacent. So 12 over 9, and if I simplify that by 3, I get 4/3. Okay. Oh, is that the bell? That is the bell. Is that how they always sounded? Oh my gosh, I forgot how they sounded. Wow. All right, guys. So we'll finish this tomorrow. We will finish this tomorrow. And if you have any questions, let me know. If you have any late work, let me know. Have a great day, and I'll see you tomorrow. Bye, Mr. Davila. Sorry. I'm forgetting everything.